Okay, so we are going to start our unit on surface area and volume. The first half of the chapter, we're going to focus on surface area, which is the area on the outside of a three-dimensional shape. Okay, and in this lesson, we're going to specifically look at prisms and cylinders. So let's look at prisms first. So they have the following characteristics. First of all, we always have the bases must be congruent polygons that are parallel. And in fact, we always have two bases. So you always need to have a matching base 1 and a matching base 2. Keep in mind, a prism doesn't always have to be set on its base, so it can be sitting sideways. So you always look for the two congruent polygons that are parallel, and those are going to be your bases. The rectangular faces, okay, these are called the lateral faces, and they always intersect at what we call lateral edge. So lateral edge are just like all these line segments that connect everything. The height, or the altitude of the prism, is the perpendicular distance between the two bases. So whenever we're looking at the height, it's always the distance between the two bases. So again, sometimes the height, if you have a prism, and let's say here it's a triangular prism, okay, here's the base. So these two would be your bases, so that would make this the height. So that would, we don't want to necessarily say the height is this, because that's just the height of the triangle. Now the lateral area is everything but the two bases. So those are all the areas of the rectangles. I'm not going to focus too much on lateral area because we just want to find the total surface area. So that's going to be all the way around plus the two bases. So here we have a hexagonal prism, and let's look at how we would find the surface area. So let's look at, we'll look at the lateral faces, and then we'll look at the two bases. So the lateral area, so if we think, probably you did a little bit of this in middle school, when you're finding lateral area, you're basically just adding up the area of each face. So if we look at each rectangle, so for example, the area of this rectangle would be base times height, so that would be A times H. If we look at this rectangle, the area would be base times the height. And then we look at the next rectangle, which would be base times the height, and so on. So I could get the next one would be D times H, then we would have E times H, and finally F times H. Now, what do we notice these all have in common? They all have H in common. So if I were to factor out the H, I would be left with A plus B plus C plus D plus E plus F. And what do all of those values add up? What do they represent? They represent the perimeter of the base. So what we can do kind of to abbreviate this is we're going to just look at just the perimeter of the base times the height. So to try to simplify it, because we don't want to have to write this all out. That's kind of annoying, right? So we're going to simplify it by just finding the perimeter and multiplying it by the height. So that takes care of all the lateral area. Then to find the total surface area, so we're going to take the two bases, right, and we're going to add those together. So we'll have 2 times the area of the base plus, and then we'll add in the perimeter times the height. So at the top of page 2, we see the actual formula for that. So the capital letter B stands for area of the base. And height, remember, keep in mind the height is the distance between the two bases. Okay, and again, that capital letter B, whenever you see that, that is going to always represent area of the base. Okay, versus a lowercase b, that would represent the base of just one face. Okay, so we want to find the surface area of each prism. We're going to round to the 100th place if necessary. Okay, so two things I need to find, right? My surface area, and you can use an S, or I think on my worksheets I have SA, so 2 area of the base plus the perimeter times height. Okay, so first thing you want to do is identify what is your base. Okay, remember you have to have two that are parallel congruent. That means this right triangle and the one just below it, those are our two bases. Okay, if it helps, sometimes you can draw, like I see this is a right triangle, so if it helps, draw the base over again. So this would be 8 and this would be 9, because that's what we're working with, right? This is the base we're working with. So I need to find the area of that base, and I have to find the perimeter of that base. And then the height is the one measurement I haven't used yet, and the height, again, the distance between the two bases, is going to be 5. So here I need to work with the area of the base. Well, it's a right triangle, so we'll do base times height divided by 2. So our area of the base is going to be 36. And then for the perimeter, I need to use Pythagorean theorem to find that third side. So we'll have 8 squared plus 9 squared equals x squared. So we'll have 64 plus 81. So I'll just write square root of 145, and we can plug that into our calculator later. So we'll have 9 plus 8 plus square root of 145. Let's go ahead and plug that in, and we get 29.04. So now that we have the area of the base, we have the perimeter, we have the height, we could substitute everything back in. So it'll be 2 times 36 plus the perimeter, which was 29.04, times the height. So we'll have 72 plus 29.04 times 5 gives us 217.2. We're still working with area, so this is going to be square inches. Next one. Okay, so first thing we want to do is identify which shape is the base. Remember, there has to be two congruent parallel bases. So in this case, it can't be this. That's just one of the lateral faces. The base in this case has to be the pentagon, because we have another pentagon in the back there. So I'm going to look at, again, you don't need to do this, but sometimes it helps. I'm going to draw the base. So I want to focus on finding the area of that base, and I need to find the perimeter of the base. Well, perimeter is easy, right? Perimeter is just going to be 14 times 5. It's a pentagon. And now for the area of the base, we're going to do perimeter times apothem divided by 2, because it's a regular pentagon. Now, if this is a pentagon, the central angle would be 360 divided by 5, which would be 72. And then when we cut that in half with the apothem, we get 36 here. And then, of course, since this was 14, this will be 7. So I need to do, this is 7 is opposite, A is adjacent, so I have tangent of 36 equals 7 over A. So that means A is going to be 7 divided by tangent of 36. So let's see, 7 divided by tangent 36 is 9 9.634, so we'll say 6.3. Okay, so now we'll go back to the area of the base. We said the perimeter was 70. We found the apothem was 9.63, and we want to divide that by 2. So 70 times 9.63, and then I want to divide that by 2. I get 337.02. So again, finding the perimeter and area of the base, that's where all the work comes in. Because when we go back to the surface area formula, right, we have all our information. So it's going to be 2 times the area of the base, so 337.02, plus, we said the perimeter of the base was 70. Now for the height. So if our base is the pentagon, right, then the distance between those two bases is 8. So that has to be our height. Okay, take a minute, plug that in to your calculator. And I get 1,234.04. Our units are centimeters, so square centimeters. Okay, if you think you have the hang of it, you want to try the next one on your own, you can pause it and then check to see. This time, our base is going to be the hexagon. So if we have a hexagon, right, central angle 360 divided by 6 is 60. When we draw the apothem, that's going to bisect it and make that a 30-degree angle. And if the whole thing is 4, then just this segment here is 2. So using our 30, 60, 90 rules, we can see that A has to be 2√3. Okay, so we have the perimeter of the base, so that'll be 4 times 6, which is 24. The area of the base will be the perimeter times the apothem divided by 2. So for that, we're going to get 24√3. You can plug that into your calculator now, or we could do that later. So we have our area of the base, we have our perimeter. Next, our height. The height has to be the distance between the two bases, so that's going to be 15. So our surface area is 2 times the area of the base plus the perimeter of the base, which was 24, times the height, which is 15. So we're going to plug that all in. And I get 443.14, and that's going to be square centimeters. Okay, again, D, if you want to try on your own, you can try it. Here I see we have a triangle, and this is not a right triangle. In fact, if this is 4 here, this is 4 here, so it's going to be an isosceles triangle for the base. So for the perimeter, we can see that that's just going to be 4 plus 4 plus 5, so that's going to be 13. For the area of the base, we need to, since it's not a regular polygon, so we're going to have to do just base times height divided by 2. So here, I'm going to draw this. That makes this 2.5, and we want to find that measure, so we'll use Pythagorean theorem. So x squared plus 2.5 squared equals 4 squared. So I get x is the square root of 9.75. So for the area of the base, I'll have 5 times square root of 9.75 divided by 2. So I'll plug that all in. And I get 7.806, so that will be about 7.81. Again, you can use the exact result and plug that back in. Your answer, sometimes it might be a little bit off from what I get. So my surface area is going to be 2 times the area of the base plus the perimeter times the height. The distance between the two bases is 9.5. So I'm going to plug that in. And I get 139.11, and that's going to be square yards. Okay, the other part of the lesson is on cylinders, and cylinders are pretty much the same idea, except for that the base always has to be congruent circles. Okay, so we know what a cylinder looks like if we think of a can, right? The height still is going to represent the distance between those two bases. And the lateral area is going around, so like if you were to take a label off of a soup can, right, that would be the lateral area. So when we're looking at the lateral area, right, thinking of everything but the two bases. So if we had taken a soup can, taken the label off of it, right, we're going to have the base of that rectangle is going to be the circumference of the can. So that would be 2 pi r. And then the height is just that height of the can. So we can see 2 pi r times h. Right? Now, what we did previously with the prism, it was perimeter times the height. But we don't use perimeter with circles, so that's why it says C times H, or you can just write that out as 2 pi r times H. So next, if we want to find the total surface area, we're just going to include the two bases. So here's the one formula, 2 times the area of the base plus circumference times the height. And then if you want to just write it all out so that you have 2 pi r squared plus 2 pi r h. So those are the formulas, right? Because pi r squared is the area of the base, and we know circumference is 2 pi r, so that's where we get this formula. I'm usually going to use this one. It's just easier for me to substitute all the values in at once. Okay, so example 2, we want to find the surface area round to the nearest hundredth. So we have 2 times the area of the base, that's going to be 2 times pi r squared, so that's going to be 8.3 squared, plus 2 pi, and then it's r, which is 8.3, times the height, which we can see is 6.6. So go ahead and type that all in. Now, if we were in school, it is nice to see exact form. So one of the things you can do is multiply this all out, and you can actually leave pi in your answer. I'm not going to worry about that so much for this problem because there's already decimals involved. So I get 777.04. Double check, make sure you got the same answer. Okay, we got 2 more examples here. This one just tells us we have a cylinder with D equals 6 and H equals 15. So D is 6, that means the radius is 3. So my surface area is 2 pi r squared, so that's 3 squared, plus 2 pi r times H. So this will give us 18 pi plus 90 pi, or 108 pi. So we'll plug that. So that's if we were leaving it in exact form, we would leave 108 pi. Plugging it into our calculator, we get 339.29, and this is square centimeters. Okay, the last one here. Surface area of a cylinder is 96 pi centimeters, and its height is 8 centimeters. Find its radius. Okay, so surface area formula is 2 pi r squared plus 2 pi rh. So let's plug this in. We have surface area is given, so that's 96 pi. and we have the height is 8, so we're looking for the radius. So I have 96 pi equals 2 pi r squared plus 16 pi times r. All right, what we need to do is isolate the variable. The problem is that we have an r squared and an r, which means we're either going to have to look to factor or use quadratic formula or something like that. First, what I want to do, I notice that I have pi in each of my terms, and I notice I have all even numbers. So I'm actually going to simplify this first, and I'm going to divide everything by 2 pi. So I have 96 pi divided by 2 pi is 48. Here we'll just have r squared, and here we'll have a plus 8r. So when we're working with quadratics, we want to get everything on one side. So I'm going to make this equal to 0. So I have r squared plus 8r minus 48. Now, we can look, let's see if it factors, because if it doesn't factor, we have to go back and think back to quadratic formula. So if I have 48, and I'm thinking two numbers that multiply together to give us negative 48, and when you combine them, you get positive 8. So that's going to be a plus 12 and a minus 4, which means when I set each one of these equal to 0, here I get r is negative 12, here I get r is equal to positive 4. Obviously, a radius can't be a negative measure, so we're going to cross that one out, and that means the radius is going to have to be 4, and that'll be 4 centimeters. Okay, so you are going to do the worksheet for this lesson, and then we'll come back and we'll check back in when you're done.